We're going to be working out of your textbook on chapter or lesson 29, section 1. That is page 445. And as you can see, the simplified problems where they ask you to simplify or reduce this fraction starts off quite complicated with you having to factor these trinomials. The assignment that you're going to work for me on Delta Math is going to include a few simpler problems. So I'm going to review with you. Yes, I'm going to review with you how to simplify before we go to multiply and divide. But I also want to start a lot smaller than these problems. I also want to give you a heads up. You will be factoring, okay? There is no way around this. If you're not very skilled at factoring, now's a great time to practice. However, I will model the factoring, but I am not teaching the factoring. If you are not understanding what I'm doing during this factoring process, then you need to go back and watch the factoring lessons. I'm pretty sure it's way back in semester number 1. I may even have that module locked, but I will go back and unlock it for sure so that you have access to the factoring videos. I'm going to say it again. I will not be teaching the factoring. I will be modeling how to factor, but if you're not understanding how I'm doing or why I'm doing it, then you'll need to go back and watch the factoring videos. Factoring is expected. Okay, so way back in, I don't know what grade you were in, 3rd grade, 4th grade, somewhere around there, you learned how to simplify a fraction. And you may have started off with something, probably not with variables like this one is right here, but it might have been something as simple as the fraction, why is my pen being stupid, 2/4. You learned that when you are writing fractions, you have numbers in the numerator and numbers in the denominator. You may cancel out, and I will again explain that I don't like the word cancel because it means so many different things. What we really should be saying, you can divide some common factors out. You factor this. Factor, if you don't remember what the word factor is, a factor is a number that you multiply. So the factors are of 2. The factors of 2 right here, I'm asking you what numbers do you multiply together to get 2? 2 only has 2 factors, 2 and 1. It's called a prime number. Factors of 4, I'm going to use the factors 2 and 2, and the reason that I'm using 2 and 2 instead of 4 and 1 is because one, we don't really cancel the ones out or divide them out because they are 1. They don't bother us. We don't put them when we don't need to. So we're looking for common factors. So I factored the top number into 2 times 1. So I wanted the bottom number to also see if it had a factor of 2. And it does. So that's why I used it, because we have a 2 on top that's going to reduce out with the 2 on bottom, because what's the value of 2 over 2? 2 over 2 reduces down to 1. So that's what I'm doing. I'm reducing those two things down to a 1. And so now I have 1 times 1 on top, which is just a 1, and I have 2 times 1 on bottom, which is just a 2. So that's a lot of words and a lot of work to say 2 over 4 reduces down to 1/2. The same thing applies to this problem, 5x cubed over 60x, and the same thing is going to apply to these two problems up here when we have a trinomial divided by a binomial, a trinomial divided by another trinomial. We're going to cancel out common factors. That's why nothing up here is ready to cancel, because there are no factors up here. So let's go back to this one. So we're going to factor this. That's just 5 times x times, I'm going to write this as x squared. Let me go ahead and do it the other way. Let me go ahead and do 5 times x times x. I'll explain why I wanted to write x squared, but we know that 5x cubed means 5 times x times x times x. And on bottom, 60 is 5 times, what, 12? I'm using my calculator to check. Yes, 60 is 5 times 12. There are other factors of 60, but I chose to do 5 times 12 because I had a 5 on top, so I knew if I had a 5 on bottom, they would divide out, leaving me a 1. So 5 over 5 becomes a 1. That reduces down to 1, and one of these x's with one of that x down there will also divide out and leave us 1. So on top now, I have 1 times x. That leaves me x squared. And on bottom, I just have a 12. So the simplified form of this 5x cubed over 60x is x squared over 12. Okay, we're going to look at the next couple examples that I have down here. Common mistake that a lot of people make with this problem right here, the 2x over 2x plus 4, is they think that these two things right here can reduce out to 1. We have a 2x and a 2x on top, a 2x on bottom, so they want to reduce that out. The problem with that is that this 2x is not just a 2x. It's a 2x plus 4. That plus sign right there makes this 2x not be a factor, but instead it makes it what we call an addiend, because the two numbers that you add together, those are called addiends. You take one addiend, add it to another addiend, and you get a sum. Addiends do not cancel out. Now, that's not saying that this won't reduce. It certainly will. But what I have to do is make sure you understand 2 on top and the x on top, those are factors. These two things right here are definitely factors because that is multiplication. So if we have a factor of 2 on bottom or a factor of x on bottom, they will cancel out. But the problem is I don't have any factors on bottom that are not addiends. So what I have to do is see if there's a GCF in that denominator that I can factor out. And there is. I can factor out a 2, undistribute a 2 from that binomial that's on the bottom. Now I do have a common factor. 2 is a factor on top, and 2 is now a factor on bottom. So these 2's will divide out, leaving you a 1. Be careful. Students still want to try to reduce the top x with the bottom x, but it does not, because that's not an x, that's an x plus 2. If it's an addiend, it's attached to whatever it's adding to. It will not factor unless you can factor it out and make it become a multiplier. So this 2x over 2x plus 4 does reduce, but it will reduce down to x over x plus 2. And again, the only thing that this x plus 2 will reduce with is another x plus 2. So you can't do anything with the 2x and the 6 and the 5x and the 15 unless you factor something out. There's a GCF of 2 on top. There's a GCF of 5 on bottom. And once I have the GCFs factored out, I have an x plus 3 on top and an x plus 3 on bottom. Those will divide out, leaving me a big fat 1. So that's 2 times 1 on top, 5 times 1 on bottom. So the reduced value is 2/5.